Hey guys, today we're working with graphs. However, these graphs are going to be a little bit different than what you're used to. These ones are actually the underlying connections between the information inside of a program. Let's get right into it. So when you first run the program, you're going to notice two different sides as far as the program. On the left side is the game, and on the right side is what I'm going to call your map, basically. The left side is where you'll actually get to move through and try to collect resources. However, it will tell you that if you try to go to a spot that is not actually accessible from where you currently are, you will get a message that says it's an invalid move. Okay, so over here you'll notice 3 yellow circles. Those are going to be the resources that you need to collect in order to complete the game. Now, you can't just go straight to them because you start up here at the town, and if you notice over here on the map, in order to get the plains, you can't just jump right to it. You have to go through each one of these. So this is how this game is going to kind of help you visualize what these graphs are and how they work as far as the underlying code. Without just staring at the code, this helps a little bit. Okay, so I'm going to show you here. Alright, so you also have these little blue rings. So anytime you're at a certain position, it's going to automatically look for the next places that you can go from there. So it's going to give you the next options as far as where you want to move. Now, let's say I go to the forest. It updates. I can go back to the town, or I can go to the mine or to the cave, because if you look over here, the big red one is where I'm at. So it shows those 3, the town, the mine, and the cave. Now on here it's green, just so you know that's who you are. Let's see here. Now if, let's say I want to go to the plains, okay, I can actually go down here and switch the mode from move mode to path mode, and this is going to allow you to create a path that you can visualize so you know where you need to go in order to collect your resources. So you select a starting point, which in this case I'm going to select where I'm at, which is the forest. I'll click that, and then I go down here to plains, since that's where I want to go, and I click that. Immediately you're going to see a path of where you can go as far as traveling. Now, for the sake of this, yes, it may not look like it's in the right spot, but if you go based off of the actual graph that is inside the code, which we'll get to a little bit more in it once we get there, the town is actually the next one in order to get back to the river. Can be a little confusing, but that's what that map on the right is for. Alright, so we'll start by going to the town. First you gotta switch back to move mode. So now you go to the town. Okay, now you can access the river. Then you can go to the lake, and now you can go to the plains. Now you'll see that the resources have been won, so that means you've collected resources. The goal is to collect 3. If you collect all 3, you win. You can try again. Throughout the game, it's going to detect how many moves you take, and at the end it'll tell you how many it took you to complete it, and you can actually try to see how many moves or the least amount of moves you can complete the game in. Alright, down at the bottom here, this is just your instructions as well as controls. So you've got the restart, so if you want to restart, it'll automatically generate 3 new points. If you don't like yours, try it again. This reset path is for when you're in the path mode. So let's say I select river to swamp, and then, oh well, I don't want to go that way, so I can reset the path and choose somewhere else. And now it picks a path. On the right side, at the bottom, you'll notice a bunch of words, but this is essentially just giving you what it would look like as far as the paths, as far as the different algorithms. So with the BFS traversal, that one is simply just going to go through the entire graph all at one time. Whereas the, pardon me if I don't know how to pronounce this, but yeah, I'm not even going to try that. The path, that one's going to start with the town and then look at where you're trying to go and automatically give you closest path. Both of those were the A star and that other one that I can't pronounce. Will give you the quickest path that you can get to, and it will actually update as you go. So if I click on gotta go back to move, my bad. If I click on river, alright, now it's going to look at the next one that I can get to. So it's automatically trying to tell you what the quickest path to get to where you need to go is. Alright, if we go to the code, I'll show you a little bit about what this is. Okay, so there's a lot of code here. Majority of it is for the graphical interface. It takes up the majority of this, so I'm not going to focus on that. I'm going to focus on the actual graphing and algorithms. Okay, so for the graphing and algorithms, you will need the NetworkX imported. This is Python, just so you know. This is a library that is going to help with working with the graphs and making sure that you can use it in whatever you want to use it for. Then you need math, so that's going to be for the A star as far as the function, because it needs to be able to do certain math operations in order to complete the function. Alright, so this resource game map here, this is just where it sets everything up, gets everything ready to go, selects the theme, you've got setting up the different font sizes and the colors for the buttons and things like that. And then you get to the actual thing. Alright, so this here, the create game graph, this function is actually going to set up the graph. So it's going to start by setting graph to nx.graph. That is essentially just calling upon that NetworkX library to create an empty graph, so that way it's ready for you to put in your information. In order to do this, you need two things. You have to have nodes and edges. So the nodes are the information, so each little dot that you saw on the graph back in the program, those are nodes. So each, in our case, it's location. So because of the game that we're playing, I wanted it to be locations. It can be anything. It can be just having a mind blank right now, but so like if you're doing networking and stuff like that, you can have the different IP addresses and things like that. Or let's say you're having an inventory type thing. It can be all the different items within that inventory. Then you've got the edges. So these edges here are going to be the connections between the nodes. So where can I go from one node to the next? So in this case, if I want to go from the town to forest, I have to tell it I can go from town to forest, town to river, forest to mine, things like that. You're giving it the different connections so it knows later on, hey, either I can go to that spot either I can go to the forest from the town, or I can't go to the forest from the town. That's just to help make things easier. And these here are just adding it to the graph. So you start by providing a list of all of the different nodes that you want. You add them. You have a list of edges. You start with the edges. You want to make sure you put your start location and in your end location. Because if you try to do it backwards, then when you try to start, so let's say that I wanted this to be start at forest, end at town, that would mean I can go from forest to town, but then I can't go from town to forest. So next up is the generate resource location. So for the sake of this, it doesn't really have a whole lot to do with the actual graphing itself. This has to do with the game. So this is essentially just going to go through each node on the list and pick 3. It's going to pick 3 random ones. That's why every time you reset the game, you'll have 3 different locations. And it's going to pick 3 of those and then return that, so then it can be used later on to display which ones you need to access. Let's see here. Got the calculate node positions. So this one again is for the game, so it's going to determine where they need to go on the canvas, which is what's used as far as the graphical interface to be able to put them all there. Again is the setup UI. Let's see here, find the next. So, okay, I guess I'll explain this a little bit. So the highlight valid moves. So this is going to check to see if the selected node that you have that you're trying to go to can be accessed from the node that you were previously at. So if you're trying to go to the forest from the town, but that connection's not there, it won't let you go. That's where you get the error message. If you do, then it will go. Oh wait, I'm sorry, I got that mixed up. This is the highlight. So this one is actually going to automatically check and look for the next valid moves from that spot. So it's not going to look for, you know, the whole path that you, all of the different paths. It's just the very next move that you can take. So it goes based off of those edges that we provided. It's going to check to see if it exists, if that edge exists from that current one, which in this case from the town is where it starts. So it's going to look at the town and see what connects to that I can travel to. And then each one of those that it can travel to will be highlighted in a light blue circle. That's all that does. It just creates a circle to put over it. Let's see here. Here we go. Okay, so the perform algorithms function is going to complete the traversal and pathfinding algorithms and then display the results within the graphical user interface, also known as GUI. First up, you've got the BFS nodes. So we have to set up the BFS first because well, you don't have to set it up first, but I'm going to just because it's outside of the if and else statement. It doesn't have to be there because of the fact that it's going to be going through the entire graph instead of just certain sections of it. Because with the BFS, that's the literal definition of a traversal. You're going through the entire thing from start to finish, showing every little spot that you have visited. So what you do is you give the list of all the different nodes within your graph, and you give it a starting point. So we have to tell it to where it's going to start at, so it knows where to begin and where it needs to branch off to as far as getting to the rest of the spots. And then it's going to display that to the result label for the BFS. Each one has their own label, just to make things easier. And then you've got the resource locations. So the resource locations is in itself, I mean, it's the same thing as what the self does, but you're setting it to another variable so nothing gets screwed up. So you're going to set this resource locations to get those randomized locations that you got earlier. So those 3 different locations that you got as far as where you need to go to collect your resources, that's what those are. So once they're generated, this here is going to call upon those to get it. If those resource locations exist, then it's going to call this here and run each function. Oops, sorry, didn't mean to highlight the except. It's going to call each one of these, the A star and the one that I cannot pronounce, to start at the town and tell it to go to each location, or to that resource location within each list, within each function. It will start at the town and then it will work its way, giving you the quickest path to get to your resources that you need to collect. Then there's the accept. So this one here, if it doesn't happen to find a path between where you start at and where you're trying to get to, it will tell you that. It will display a little, both labels will tell you that there's no path, so there's no way to get there. Now this else down here is the exact same thing, except only it's meant to be if there are no locations at all. So if something goes wrong and for some reason it doesn't generate the locations or something like that, it's going to tell you that there's no path available because of the fact that there's nowhere for you to be able to go because those resources don't exist. Okay, again, I can't pronounce that name. I don't know why, but yeah. So you've got the whatever search. this is going to perform that specific algorithm to find the shortest path. So it's going to look for the path that is the absolute shortest. So you're not making a bunch of, going back and forth for no reason in order to get to your destination. And then you've got the heuristic. So this function uses the straight line distance to know what the quickest path to go will be. So as far as it gets the different distances that you then have to put in here, you have to put in the positions of where they're at, and it will calculate those. Why you needed the math, uses this math calculation here to be able to determine the distance between each one, so then it knows which one to do. Because let's say that from the town to the lake is 20 feet, okay, but I need to get to the forest, okay, so let's say I have to go from the town to the lake to the forest, or I can go from the town straight to the forest. Okay, well, if the town to the forest is 45 feet, and we already said the town to the lake is 25, ooh, I did not mean to move that, is 25 feet, okay, but the lake to the forest is 30 feet, well, that makes that 55 feet to go from the town to the lake to the forest. So then it's going to look at, okay, well, the town to the forest was only 30 feet, so it's going to be quicker to go straight to the town to the forest. But if it was reversed, and from the town to the lake was 15 feet, and the town to the forest was another 15, or the lake to the forest was another 15 feet, but the town to the forest itself was 45 feet, it's going to go from the town to the lake to the forest because the distance is shorter. That is what the A star, sorry, I had to think of the symbol, the A star algorithm is going to do. It's going to be checking the distances between each one of the nodes to determine which one is going to be the quickest. Then you've just got the main, and that is pretty much it. I think that's all for now. We'll see you guys next time.